All right, so in week two for cyber operations, you guys should be able to scroll down and see stuff in here. Week two should now be visible. And inside week two, you're going to see all the module one stuff. So I noticed a couple of you guys went in and found like discussion boards and some other stuff that was in there. That's gone. Like it's gone.
Okay, we don't have to do that. Okay.
I don't want to do discussion boards unless you guys thoroughly enjoy them. I don't find them an effective training tool. So it's busy work that doesn't seem effective to me. So those have all been removed. This is what you should see at the beginning of every week, and the other ones are going to actually start on Sunday at midnight. They should auto release and show up there. So you'll see the overview that will give you an idea of what you're going to have that week. For the most part, almost all these weeks are going to look similar, and that you'll have some lab assignments, and then you'll have a quiz. Yeah.
Did you put the due dates on there?
Not yet. I'm trying to figure out how to do that in Ultra.
Okay, I just didn't know if I missed something.
It doesn't give me those options. So if I find it, I will definitely put them in there.
But it's just going to be something new each week, basically due by Sunday.
Yes. So you'll have quizzes like this one that'll pop in, and then so all those will be due at Sunday at midnight. Is my standard due dates. So like lab assignments this week, you guys have, I believe there's 3 labs. So you'll have 3 labs in there, and then you'll have the quiz, and that'll be your guys' most assignment.
Is that all due Sunday?
All Sunday at midnight. Yep. And then the reading material, obviously you'll have the modules, and you guys should have access to that. This is pointing you out to the reading materials. You can either get that from the link when you purchased, or you can come into the PDF up here at the top, and you can just download that to your machine and go to module 1. So however you guys want to do it. If you use theirs, you're going to have the web GUI with like a click next kind of thing. Otherwise, if you'd rather have the PDF and throw it on your Kindle or some other way of reading, you can grab the full PDF and do it that way. All right. Like I said before, don't get distracted by like module 1 if it's quote 100 pages, right? Because a lot of that is pictures and things like that, diagrams. So don't get distracted by the page count. All right. So the way this will work as far as class periods is on Tuesdays, we'll go through the PowerPoint portion of it. And again, if you guys have seen me on PowerPoints, I'm not going to read every single slide in a PowerPoint. I'm going to give you the highlights and what we need to know in order to pull off the labs, as well as what you guys will need to note for when we do the challenge CTF stuff here after the midterm. All right. Just again, is to highlight that stuff after midterm, and that employer reiterated exactly what I was hoping for is he doesn't want step-by-step instructions. For example, like these labs are going to give you step-by-step instructions on how to get through the lab, right? When we get to the other side of it, it's here's a tool. I want you to go deploy the tool. No, I'm not going to give you instructions, and no, I'm not necessarily going to help you. The idea is that this is what would happen in the real world, and it does happen. I think you justified and mentioned that the other day in summer, that you guys have to figure that out. And those skills are the ones that the employers are calling right now, asking for. So being able to troubleshoot on your own, go do some research on how you get it installed, et cetera, et cetera. Obviously, I will still lead you in the right direction, but his goal is that other one's in there. And he's hired a lot of ours. Our other plan with that scenario is in the future, we'll have up to 5 internships locked in with that company that would rotate out of this class. So if you came through this class, have material and other things, it would prep you for being able to go into that internship during that time. All right. Let's fire up the PowerPoint side. All right. I may walk and talk for those online. If you guys can't hear me clearly, let me know. The microphone, in theory, should pick that up without issue. Let's see here. I'm going to pause the recording real quick. All right. So this first week, this first module and whatnot is really going to be focused on bringing back those fundamentals that you guys should already have under your belt from Internet Working 1, Internet Working 2, core concepts of networking. So just a recap of the TCP/IP model. OSI model, different types of networks, the topologies, the hardware components that make up them, the TCP/IP protocol suite, network security controls, devices, Windows, Linux, web, like 12 different topics in this module, pretty big module. But it's meant to be as an overcap and a reveal, if that makes sense. So as a computer network, this is where you're going to see over here on the left is kind of the basics of the SOC and understand the computing, standard computer networking, Windows operating systems, things like that. And then as we moved into a traditionalized, centralized computer center with distributed data in our data centers, and then computer networking basics, anything that involves interconnected systems with the different technologies for doing such, distinguishing between computer networks and distributed systems for endpoint users, and then the overlap between distributed systems and computer networks. We also talk a little bit about the motivations for computer networks, home IT, mobile computing, social implications of computer networks, and resource sharing. Let's see here, we're good there. I think we talked about most of that. So let's get right into that. Remember your TCP/IP model. So you have the transport layer at the top. Remember, this does not match up with the OSI layer. That is this one. Everybody remember the difference from internet networking one? Somewhat, kind of, shorter. So the idea here is that the TCP/IP rides over the top of the OSI, right? So OSI is kind of the basic foundational, where one is going to be talking about your physical layer down here at layer. That is completely backwards of the way it's supposed to be. Does anybody else recognize that? Yeah, so don't look at that graphic. I'm not sure why they have it that way because that is completely inaccurate. The physical layer is layer 1. So layer 1 working all the way up to the application layer of layer 7. That's disturbing. Okay. Either that or they're just trying to keep us on our toes, right? Same way here, by the way, this is flipped. I'm not sure why they put it in this direction because link layer would be 1 moving on its way up for the TCP/IP model. So this is why you can't trust resources, right?
Brain must work differently. Maybe they're, I don't know.
Some of the individuals I've worked with, they do stand on their head. So,
yeah.
All right. Transport layer is positioned below this application layer. Let's go back here. So the idea behind TCP/IP is reliability. So we've talked about TCP being reliable. And you remember UDP is much faster, but less reliable because we don't do any what?
We just a question.
So on TCP, what do we do different than UDP? Yeah.
With TCP, you establish like a 3-way handshake. So you have to establish that connection first, while UDP is connectionless.
Okay, that's good. Connection versus connectionless. What else do we do?
TCP is confirmable.
Yeah. In other words, with that 3-way handshake that stood up and make sure there's a connection, we also verify the packets as they come across, right? And if they are not, a packet gets dropped, we ask for that to be resent, where UDP just blasts it to us. And if we get it, great. If we don't, we don't. Where's a good use case for UDP? Or where do you typically see it in networks?
Over the internet video.
Video? Yep. Any other place we see UDP?
What we're getting there is like unimportant versus like verifying like phone.
Right, I'm looking for application wise.
Like
phone, there you go.
Like
phone and voice, right?
Phone, voice
so voice, video, those are all UDP things where we send the packets. If one drops out, we're okay. We still understand the conversation going on, right? If we lose a frame in video, we notice a glitch, but the video moves on and we keep moving on, right? You've seen this in your Netflix. You've seen this in other stuff where you drop a frame or maybe it gets fuzzy and compressed and then comes back out. That's all based off that. TCP is more if we're going to be doing file sharing, if you're downloading files, if you're doing anything that critical that we want to verify the data actually got through. Cool. Let's let's see here. That's kind of the highlights of what you need to know on that side. On your internet layer, which is just below it's not below, it's above the transport layer. It handles the logical addressing and the routing of data packets across different networks utilizing IP addresses, right? So the idea here is that we typically either have IPv4 or IPv6. And you guys may have noticed that there's not a whole lot of IPv6 out there, although that was a huge push even back when I was in school. That the Chicken Little, we were running out of IP addresses and the sky's falling, and then nothing happened, right? I know most of you don't remember this for Y2K. Maybe one of us remembers Y2K.
A little bit.
But the rest of you, I assume, don't remember Y2K, which was a huge deal in the computing world where the clocks were only written to go to the end of 1999. And then when 2000 came, the millennium was going to crash all the machines.
Well, you had to buy a computer that was Y2K ready.
That was just a huge marketing sale, right? Yeah. Which was great.
Because we had 2 computers that were Y2K ready.
Yeah, you were fancy.
We were.
I just started back over in 1900, but whatever. So the idea there is IPv6. Does anybody know where IPv6 still took off and is required as of today? You should know.
I remember the big scare when it first happened.
Right, but there's a place even today where IPv6 is required and is implemented.
I should know this.
You should know this.
IoT?
Not IoT. Government.
Also, the military.
Anything government and military is all IPv6.
I know, like, we had to do IPv6 as soon as we had it for the draft standard. Because I remember implementing the draft standard in our things.
Almost anything that is government related requires IPv6 be deployed.
Because I think I can say this, like, it's called Link 16.
Mhm.
It required that for internal network traffic.
And I've worked in this case like with the national labs, and those all had to be IPv6 based on that side. So otherwise, you guys typically won't see it. And the idea there was IPv6 gave a significantly larger number of IP addresses on the public side. You also didn't have to worry so much about public versus private and this and that. That all turned to be a farce, and that NAT just really solved all of that for the most part. It did get us to clean up some IP addressing along the way and return IP address blocks that didn't need to be there. Okay. OSI layer, the main thing that you guys need to know out of the OSI layer is when you guys go to troubleshoot, think these layers and work your way from the bottom up. So when something doesn't work later, when we start doing the hands-on stuff and you're working with stuff, start at the bottom up. Start with physical. And sometimes we always call it layer 0, right? That's you. You are layer 0. So did I plug the cable in? Okay, cable's plugged in, got my physical. Do I have a link light? That's my data link light, right? Layer 3, do I have an IP address? Is IP address stuff working? AKA, can I ping somewhere? Is it routing going through there? Okay, pings and that kind of stuff work. Now, am I getting communication on whatever type of traffic that I'm trying to go through? That's your transport layer on up through session, presentation, and application. All right, so if I'm not able to pull a website, but I can ping the server, that means that I probably have layers what? Don't look at the ones on this screen because those numbers aren't accurate. Flip those numbers upside down. A ping will test what? You think it'll go 4? So up through transport?
3 and 4.
Yeah, it's kind of 3 and 4, really. And the reason for that is you still have to set up the transport layer because we are sending what kind of packet across. If I'm doing a ping, I'm sending what kind of packet?
ICMP.
ICMP, right? Extra credit. What type of ICMP packet?
When I do it at home, it says
We know ICMP, but
in Wireshark it says who has. That's
There is that part. That's what protocol is that actually? That's not, yeah, that's ARP, right? So ARP will come back and give us, what does ARP usually do? What's the purpose of ARP?
To map the network.
At the table.
Look at the table to find what? You're correct, but
Yeah.
there's a specific address ARP is looking up. Or what is it doing?
Who is internally saying,
That's
they're also
I
saying,
mean,
tell this person.
What is it translating?
IP to back.
IP to MAC. That's correct. So remember, the ARP protocol is what translates your IP address over to your MAC address so that it knows and tells the switch when it encodes the packet, this is the destination MAC address. The switch finds that destination MAC, associates that with a port, and sends it out that port. All right. So you're correct. If you look at a Wireshark, it'll say who has 192.168.1.10. The switch generally responds and says, this MAC address is associated with that IP address, in which case that traffic will then send all the way through. Which is why we can, as cybersecurity, poison the switch to say, nope, it's not that MAC address, it's actually my MAC address, and then you're sending all that traffic my way coming through there. And you guys will do some man-in-the-middle style attacks too. All right, all of that's important in this side of the house because just the basics of getting something stood up like a server that you guys are doing, you'll have to be able to get pings to go through. Now, if a ping doesn't go through, does that mean that communication is not actually there?
No.
Great, why wouldn't it? What would be allowing traffic but not pings?
The device or the router.
There's one other device that we typically would have, either software-based or hardware-based.
Firewall.
There you go, firewall. So just because you can't ping something doesn't mean that that device isn't up and running. It's more than likely either got a firewall, which a great example of that is Windows machines. When you guys are setting up this environment, when you send off pings to a Windows machine, does it work by default? We got a lot of work to do in this class.
Well, the
no,
Tiger
well, I
Tape
want
one
to say
too.
yes, but you're framing it as no.
No, it's correct. Pings do not go through by default on a Windows machine. Windows Firewall blocks all ICMP traffic by default.
Yeah, those.
So if you do a fresh install of Windows, it will immediately block all pings coming in.
Really?
You have to go in and turn off the Windows Firewall or allow ICMP traffic to come in.
Mine lit when I installed Windows 11 on this, it lit whatever I wanted.
I swore that you. No.
Shouldn't, because that was a default thing for Windows for a long time unless something in Windows 11 changed.
Because when I made this one, that was the first thing I did was see if because my network card wasn't working.
I feel like
I
we
plugged it with
pinged each
Ethernet
other.
and it responded to a ping. Now it didn't say
From
anything.
another device? Usually it
It
doesn't.
even came back with the host name.
Now that's done through NetBUI, but
But I mean, I did that second, but like when I pinged it, it did respond.
yeah, that's unless something changed in Windows 11 I'm not aware of. That was a huge thing back in the past when we were always troubleshooting things, is that the default Windows Firewall always blocked ICMP
They
traffic.
probably fixed it. Mine probably I had a canary, so it probably broke and they fixed it. So
But so double check it. That's back to the point of just because you ping it and it doesn't show up doesn't mean it's not up. It's a software-based firewall, in this case, at the PC level that would be potentially blocking it. Now, we could also be blocking it higher up the stream on the firewall. So those of you that took 686 with me last spring with Palo Alto, you guys would know that we can, by default, allow internal traffic, or we can override that and block certain traffic even on the same LAN segment. So we may want to block pings and things like that. Does anybody know why we would want to block pings on the same network?
Hides you from easily being found.
Yeah, right. I mean, we generally associate if a ping responses, then we know that host is up, right? What kind of tool would you be using to find that?
Nmap.
You got it. So Nmap, an IP scanner, that's typically what a hacker or somebody doing a pen test on your network will start with, right? We start with a ping test, just see what's up. Then we run fancier ping tests that say, okay, ignore the ping, but also still scan what's going on. You guys have ran some of that in map scans and things like that. All right. So again, it's important to have this all in your head to say, all right, I have an issue, start at the bottom, work your way up. And if you guys can technically think in that pattern, a lot of this will go so much easier. Just start at the bottom. Do I have a link light? All right, great. Do I have a MAC address? MAC addresses are working. Do I have the next section where I can ping or at least have some kind of network connectivity, et cetera, et cetera. And then work your way on up the layer. Okay. Let's see here. Types of networks. This is just going to kind of reemphasize the different network models that you guys would have learned in Internet Networking 1 and 2. And the difference between the client server model, which is real popular for scalability, meaning that servers are in a client server model are going to have their own RAM, CPU, storage, network, et cetera, while the clients are usually self-sufficient computers. So we're going to be distributing data out to all of our clients from a server model platform. In a peer-to-peer model, you're going to see an equal sharing of resources among all computers, which is suitable for small networks, but not really scalable. This is more of what had been like a mesh or a full mesh network back in the day that we would have done off of like Token Ring or things like that. But you don't typically see that model as much anymore. You will see it not so much at a computer level, but at a networking infrastructure level, you will start to see something like that. Okay. Couple other types of networking. You have your PAN, which is your personal area network. This is really something small. Think Bluetooth, right? This is something where you have your mouse, your mobile, your keyboard, a monitor, things like that. That is considered your PAN. Okay. Specifically things like Bluetooth, where you can actually set up a network just on Bluetooth and you can actually communicate in that path. You guys have done this on your computer, in your car, when you're listening to radio, et cetera. That Bluetooth protocol is setting up a personal area network. You also have a LAN, your local area network. This is usually meant to be within a single geographical location. Therefore, it could be confined to something like your home or your office or a campus, and they're all facilitating local sharing of resources, data, services, et cetera. So you would have your local area network with wired connections. You could also have a wireless connection connected in there, like your access points up above, your printers, your fax machines, photocopiers, laptops, desktops, phones, et cetera. And then when you get to a WAN or a WLAN, this is the wireless side of things that we just talked about before. And it's just adding the wireless capabilities to a LAN. Typically, this is meant to blast through, and most of the protocols you guys will need to understand is just knowing what 802.11, A, B, G, N, and whatever they're up to now.
AX, B,
AX, Z, 3YC, I don't know.
7, it's just 7 now.
Just 7, right? So, and understanding the concepts of Wi-Fi 4, 5, and 6, and 7 right now, knowing the differences between them, it's usually speed is what it boils down to, as well as what? Range.
Like gigahertz.
You got it. Frequency, right? And that's really what kind of jives it up. So knowing whether you're a 2.4 gigahertz band, a 5 gigahertz band, or a 6 gigahertz band. And then on the 6 gigahertz band, you would have like Wi-Fi 6E or 7 at this point. I think they're still ratifying 7, correct?
It's ratified.
Not fully
You can
through.
buy 7, but
it's ratified. It's done.
It is done.
Yeah.
Okay.
MLO is still iffy, but you have like 4 gig WAM and a bunch of other stuff. 7.
Perfect. We've come a long way since the 802.11g.
I remember G and B.
I remember getting 54 meg, and that was pretty hot back in the
I
day.
had B and I had 11. I'm like, I never need more speed than this.
All right, so we got all of that. And there again, they list Bluetooth here as a Bluetooth speaker. That's incorrect. The Bluetooth protocol itself would not be accurate. Now, if you have a Bluetooth speaker that connects to Wi-Fi, that would be accurate. Does that make sense? Just want to clarify because people get hung up on some of these photos. So, for example, Sonos. If you have a Sonos system that doesn't have Bluetooth, usually new stuff does, but typically they are a Wi-Fi powered speaker. That would be an example of that there. Right. Relevant to you guys as a SOC, you guys are going to have a little bit of the surveillance camera, so understanding different camera systems. for maybe you are monitoring huts or data centers or anything else going on out there. And then obviously all the other devices around there.
Wireless headphones is wrong also.
Yeah, there again, wireless headphones and not a Wi-Fi thing.
And smartwatch.
Those are smartwatches can connect these days. They can connect, but typically, again, they were Bluetooth, LTE type stuff. So, and then you have a MAN, which is what spans a city. So usually referred to as a metropolitan area network. This is going to cover a bunch of different LANs all interconnected between each other. And then the WAN, which is your typical internet type network, where it's going to connect multiple local area networks, typically using private owned or service provider links going across. We also have the concept of a SAN, which is a storage area network. It says specialized with high-speed fiber optic communication. It does not have to be fiber optic communication these days. You typically can have up to 10 gig over even copper-based networks now. Actually, you can go higher than that. If it's direct connect, you can do 40 gig, even 100 gig direct connect.
Didn't they make a 400 gig direct attach?
They do have 400 gig now for the GPUs using NVIDIA's ConnectX.
Yep. So they have 40 gig RJ45. That's as high as that can get now.
On RJ45, yeah. Those have to be extremely hot.
Yeah.
That's all I can think of. So, cool. Anybody have any questions on the concept of different types of network? Again, this should be a review from what you guys have done in the past, but you guys need to remember those concepts. So other network topologies, the biggest thing I can tell you guys is anytime you get into a system or you're designing a system like you guys are going to be doing here towards the middle of the semester, draw it out. Find a whiteboard, draw it out. I do this when I'm sitting on a phone call, troubleshooting with a customer or whatever else, I start drawing out the topology. Because the moment you do that, you can start analyzing what piece might be broken in between there, right? Most of what you're going to see here, the ideas of bus and ring and that kind of, they're realistically gone, but you guys should memorize what those were. A bus technology would have been something like a token ring, where the way that worked is you had a big old physical thick cable, about an inch in some cases, running through a classroom. You had vampire teeth that attached into it, and then that went out to your BNC connector onto your laptop, desktop, whatever, and that got you access to the internet. As you can imagine, that token would come down, say, is this for you? Is this for you? Is this for you? It was extremely inefficient, half duplex type stuff. In a ring, same concept. This is truly token ring that I was talking about. There, a token would go around and it would go around the ring till it found the PC that it was supposed to be on. So when somebody wanted to talk, they had to grab the token, put the information on the token, send it around the ring until it got back to the PC. Most of this stuff is pretty dead now, right? Most of what we have today is more going to be around a star topology where they connect to a hub or a switch. There again, hubs are kind of dead. Does anybody ever used a hub before? Or are you all too young to know what hubs are?
I'm pretty sure it just turns everything into multicast traffic.
Kind of. So in a switch level, we have the ARP so that we look up the MAC address and know what port to send it out, right? In a hub realm, it just sent it out all ports and whoever listened picked it up and went.
Would that be broadcast?
Not really. It's in a broadcast style of what we think of as broadcast now, but in the old day, it just took it in one port, spits it out all ports kind of thing. Those were, again, like a half duplex. So like when I installed the network back when I was a kid, it was all hubs, right? We didn't have switches. Switches were awesome because one, the speed increased, and two, you didn't have all this extra traffic going around. However, there's still a use for hubs, and you may actually see these when you guys are doing security type stuff. You may have seen the little things called like Ninja Stars or something like that. And those Ninja Stars, we'll do a Google search for it here in a minute. But the idea is that you can plug in a device on this port, plug in your laptop on this port, and plug in the actual network over here. And that allows you to intercept traffic. So when you guys are all Wiresharking and wanting to pull Wireshark logs and act like somebody in the middle, you want a hub in order to pull that off. You can't just plug your laptop into a switch and start sniffing packets because you'll only see the packets that are destined for you. The only way to get around that is some switches have the ability to do a span port. If it's a Cisco switch, that's typically what they called it. And that span port would allow all traffic from all ports to get redirected to the one port so that you could see everything on it, basically turning it into a hub port. Right? Again, important because there may be cases where you're trying to sniff traffic as it's going out. And if you guys were setting up something to sniff traffic so that we could pull logs or traffic logs so that you guys can actually do analysis of malware being on the network or something else being on the network, you guys have to be able to deploy that in some form or fashion. Right? So it is 100% relevant. Okay, then you have a mesh network. This is typically where everything's kind of interconnected with each other. You could do a full-blown mesh or a full mesh. Again, you're typically only going to see those in data centers where you have interconnectivity between everything. And that way, if something fails, you have tons of redundancy going down. Tree network, this is typically what you guys would see where you see a lot of hub and spoke is usually what it is. And this is a bunch of different spokes. So you may start like at the top could be equivalent of your data center with links going out to your individual buildings here on campus, for example, right? So this machine here is going to be, say, Hammond Hall equivalent. This one here would be, say, Rarick. And then down here, you have the PCs from that building all connected to that. So and this switch tiers back up to the data center.
Or like a router switch.
Right. Just connectivity wise, it's all going to flow down. Yep. All right. There's your fully mesh network. And that's, again, very expensive to install. It's very complicated to pull off because you can get a lot of what if you're not careful. Which is caused by what? You guys should have covered this in Cisco days. What's the worst thing you can have on a switch? Loops, right? Yep. Which are basically called, uses that word you were talking about earlier with hubs.
It's sending.
Broadcast.
Broadcast what? Anybody remember that last word? Storm. So a broadcast storm is usually what it's referred to. So you can get, yes, a lot of switch loops that cause in there, which causes a lot of traffic. In the Cisco realm, we used to know when that happened because anybody remember how to identify that on a Cisco switch? All the lights are blinking in unison. If you ever see that as a tech, you know you did something wrong. That's a bad day. So, and that does work on some other switches, not always, but that I've done that. I've been there, done that. That's a bad day. Now, how do we prevent those kind of things from happening? Does anybody remember that technology?
Spanning
tree protocol. Yep. STP. Exactly. All right. So that protocol is meant where you have more than one uplink to multiple locations. It will what?
Turn one off.
You got it.
Yeah.
It will disable those other links. And then once that your main connection, it kind of does a heartbeat. If that connection ever dies, it lights up another link. And then it uses that protocol through all switches so that it knows what links are up and which connection things can flow. So extremely important because when you guys start working in data centers and stuff, typically they have this fully interconnected core. And then as you guys are building these out into little subsections, you need to make sure you don't go pull the wrong cables, right? It will cause, or the worst case, which you'll typically see if you're doing IT or anything else, people just randomly go plug stuff into the switch and not paying attention, and you'll end up with a really long cable that somebody will plug one end into the switch, and then they'll find the other end and plug it back into the switch, and you end up with a loop. It happens way more times than you can imagine. Matter of fact, we just pulled one out of a rack the other day. Like followed the cable, it went back through a hare nest, rat's nest, came back, and the other end came out, and somebody's like, oh yeah, that's the right cable, and plugged it in. And then broadcast storm took down the network. Now, in the security world, that would be more of a NOC thing where you would see that kind of stuff than you would theoretically in a SOC. But again, depending on where you work out here, especially in rural areas, you are usually one of the same. You are the NOC and the SOC all in one. And a lot of that is funding wise. So you won't see small scale SOCs because they're expensive to run because the software is expensive to run. Where in a NOC, you can use some fairly decent tools to do some network monitoring. The most expensive ones being like SolarWinds and some of the other big knock versions of that. Yeah, SolarWinds has its own bad thing, but in a SOC side, the software is extremely more expensive, so they usually cover other people's security systems as well. So most SOCs you will find are usually the virtualized version of other people's SOCs all the way through. In other words, for example, Next Tech here in town, the ISP, they used to have a NOC. They eventually built a SOC because they already had the infrastructure there. That SOC then does the security operations of multiple other companies around it, right? They need that money to come in to fund the software. So you won't see just a small person do it. For example, that job that I mentioned there, they are a managed service provider, or in this case, a managed security provider. And that's what they do. Bunch of companies contract with them to take care of just the security side of their business. They have their own IT infrastructure, their own IT people. They purely just do it from a security perspective. A lot of times it's cheaper for the company to do that because otherwise you have to staff and then buy the software. All right, network topologies. I think we covered all of that. We don't need to go into that in more detail. Let's see, other network hardware you guys will need to know, whether you have point-to-point stuff, often between multiple routes or routers, requires optimization and occasionally termed unicasting. We could also have broadcast networks, as you see over there. That's typically what you guys use. And those are to share a communication channel across all machines, with wireless networks being an example. Components that you guys would see here, this is your routers, your switches, your PANs interconnected, everything that you guys do at your home would classify in this piece here. How many of you guys have a network that you manage, whether it's your home network or work or something like that? Okay. If you don't, set up a home lab. It will benefit you greatly. And that can be some free, cheap dumpster diving pieces, literally, because I've seen these guys metaphorically jump in a dumpster to get stuff.
What I'll do too, is I work at Tiger Tech. If we start e-wasting machines.
Yeah, that's the dumpster these guys jump in.
What I'm saying is I can actually tell the staff don't, like, a lot of times they don't come with RAM or hard drive, but they come with enough that I could hold them for the class if we have them.
Nice.
Nice. Because they'll let me do that. Because they just asked me today, like, does anybody in your class need PCs and stuff? So.
Perfect. So if you guys need something for a home lab, I encourage you to do that. While you're going through this class, this would be a good time to stand up a home lab, test some of the stuff that you're doing in this class to be able to understand what's going on. Obviously, we're going to do some of this in the classroom, but especially for those of you guys that are online and such, if you don't already have a home lab, now's a good time to start trying to deploy some of these technologies that we're talking about.
And I'll keep an eye.
You can absolutely do this through virtualization. So if you have VMware Workstation, or I'm going to really hate saying this, VirtualBox or something like that, you can absolutely stand up VMs and do this kind of environment virtually. All right. This is a good overview of all the different technologies that you may run into, and the different protocols at the level that they would run, other than flip those numbers upside down. Okay. Network security controls. So things that we've done on the network security side to kind of break or protect things. You will see a WAF. Does anybody know what a WAF is? W-A-F. Note what it does.
It's a firewall.
It's a firewall.
Yeah.
But it's specifically what type of firewall?
Wireless?
Nope.
Web application firewall.
Web application firewall. Yep. So a web application firewall protects web applications by filtering. See, I was hoping somebody could just read the board up here.
Yeah.
Good work.
I mean, that's what it seems like. Filtering and monitoring, like, that's a firewall.
It is. Yep. So it protects web applications by filtering and monitoring specific HTTP traffic to prevent common web application attacks. So this would be to prevent things like cross-site forgery, CSS type style attacks, a bunch of the other ones that you guys would do within Burp Suite. Has anybody played with Burp Suite? All right, you'll get a chance to play with Burp Suite. If you don't know what Burp Suite is, write that one down, go play with it. As that is what we use in the master's program, or we train you in the master's program so that you guys can do pen testing for web applications, right? We have a SIEM, and we're going to talk a lot about a SIEM, which is SIEM, or a SIM. You'll hear it pronounced multiple different ways. And that is to collect and analyze log data and identify and respond to security incidents, providing the centralized monitoring and reporting. You guys will deploy one of those during this class. All right. So you'll need to know what it is. It's kind of the source of truth. It's everything in the network is going to send logs to it. It will then be able to analyze those logs and go through there.
What did you say that was?
SIM, this one here. A good example of that one would be something like Splunk. Splunk is a big name SIM that's in there. Very, very expensive. You guys will tend to use one like Waza will be one that we'll play with in this class. So there's another term you guys can write down and look up. There's a couple other ones you guys can play with. Network Security Onion is another easy one that you can stand up. That's a good VM that has all of this baked into one VM.
Security.
Yep, we'll talk about those all throughout this class. Network encryption is going to ensure that the data is transmitted over things like SSL, TLS, or IPsec. We have our antivirus and anti-malware solutions that are meant to detect, prevent, and remove malicious software from network devices. Network segmentation, you guys have heard, some of you I know have heard this at conferences and stuff. It's a practice that helps divide the network into segments, therefore restricting the lateral movement of threats. AKA, if I get on a management and you guys have a big, giant, flat management network, I can get access to everything, right? If I break that into multiple VLANs and then I break that even further into different routed networks, that kind of thing, then I have broken things up. So you can do that by either VLANs or even physical network segmentation. Okay. Let's see, a NAC, or a network address, or network access control, is going to be allowing you to set up a security policy for compliance and user authentication. This is, again, the other big part of what you will do in a SOC is making sure that you have policy compliance. All right. So you help establish policy at a place, and then you're verifying that nobody has broken that particular policy by accident or purpose. VPNs are going to ensure secure communication over the internet. How many of you guys use a VPN? For good or for bad?
Yes.
Yeah. See, I knew I'd at least get half a hand there somewhere. All right, VPNs are going to help set up that in that secure communication. How many of you guys have actually set up VPNs? I know at least 2, 3. Okay, there again, go find an open source firewall like OpenSense or whatever else. Stand up a VPN in there. That's one thing that we're going to do in the middle of this class, is so that you guys get access and understand the concept of VPNs. When you guys do remote jobs like the one I'm talking about, you're going to use a VPN to get back over on their network and be entirely secured on their side, right? A lot of times they will ship out laptops because they're going to have in-device management and reporting so that they can see everything that you're doing on that because you're within the company. And they also have security policies that stay in place with every one of their customers. So they won't just let you use your laptop to do that kind of stuff. We also have our firewall controls and monitoring. You guys should have learned most of that in INF322, and then back around to the WAF.
Did I take these classes out of order?
So theoretically, you should do firewalls before this. However, if you are graduating this semester, then you would do firewalls in the spring.
I did it backwards. Got it.
It's okay. I think that you take firewalls in the spring, don't you?
I've already taken.
Yeah, okay.
I take.
And I know
I take
you
it.
take it in the spring. That's what I was.
I'm taking.
No, you usually want to take firewalls before this class, so you know what I'm talking about. So cool. And I don't think I've had you in firewalls, haven't I? No. All right. I was gonna say the rest of the faces I haven't seen in firewalls class. All right, network security devices. There again, whether it's a firewall or something else, is going to be preventing all these different things from happening. All right. It's really just a repeat of everything we just talked about in the other one. Windows security. So Windows security itself is comprised of a suite of features and tools designed by Microsoft to prevent you from doing daily work. I mean, to prevent accidents from happening on the network. Things like strong authentication, encryption, malware protection, network security controls, all that's kind of baked into Windows these days. Making sure that you do regular updates, auditing, and do the threat prevention stuff is more adaptive. I will admit, in the old days, you had to have Norton security on your device to protect everything from antivirus and malware and everything else. You used to have to go buy all these big names in order to do that protection, McAfee, etc. The Windows stuff is pretty good now. It does a pretty good job, and it's baked right into the actual operating system. So they'll still use third-party stuff. For example, here at the university, we use Sophos for that, but we also use Sophos for doing in-device reporting and things like that that you guys are going to do with Waza in this class when you set up the in-device side. Right. It's important to know this side of it because you guys are end up either turning on or turning off this Windows security side, but it's also a logging thing. When we install the Waza side to where we are grabbing information from all of our Windows clients, Linux clients, whatever's out there, the Windows logs, the security logs are going to get reported clear back up to the server. So if you are on your end device and you're doing something that's triggering Windows security violations, it will get logged and sent back up to the main server, not just sit on that laptop, desktop, whatever. All right. Couple different ways to protect in Windows. You have multi-factor authentication, smart card access, biometrics, Windows Hello. Those are all for user authentication. On the malware protection, you have things like Windows Defender, antivirus, smart screen, Microsoft Defender endpoint if you guys are blowing a full-blown server type setup. On the encryption and data protection, we have things like BitLocker. If you guys have used any of the campus's machines, you know, they all have BitLocker and set up and going. BitLocker is going to do what? Anybody know?
I've had to deal with it many times.
Encrypt your drive from being externally active.
It encrypts the physical drive, right? So when you boot up the machine, it will go ahead and decrypt the drive and allow you to access the files. If that drive was, say, taken from the machine and tried to be boot up on another machine, everything would be encrypted unless you have the BitLocker decryption.
Sometimes even clearing BIOS configs, it'll.
Yes.
Yeah.
Yep. Because it interacts with the UEFI side of things and secure boot. So that one's a lot more common today, especially because we transitioned from things like BIOS to UEFI. You also have the concept of secure boot and things like that with TPM stuff being built right into laptops and desktops. So that is becoming much, much more important than it was in the past. On access control, we obviously have user accounts. That's where it always pops up when you install that little program from the internet. It gives you more RAM and says, give us full control, and you hit yes. Just know it does not, in fact, install more RAM.
Plus 128.
I had to explain this to my 13-year-old son once upon a time. Now he's in this. So, yeah, he didn't want to ask dad for more RAM, so he just downloaded it from the internet. It didn't work out well. Security groups, and trust me, this happens all the time, right? I mean, whether it's at home, whether it's out in the industry, you will see people do silly, silly things that they should never do. Click on phishing emails, click on this, click on that, and then they give away their credentials logged in. That is why we all get to have jobs. And that's why this job continues to grow and boom, is because humans. All right.
Cloud RAM is.
So the next time you see somebody do that, instead of making fun of them, just be like, thank you. I now have a job. It works. All right. Other things on the Windows security side, when you guys set up Windows Server environments, which we will get one of those kind of halfway set up, I believe. You guys did the basics and then they have to set up everything else. We will learn things like group policy, which is a central and flexible tool within Windows that allows you to configure and secure and control different user accounts across the network. You can also do it to enforce security policies, set security baselines, software restriction, all that kind of stuff. That, again, is what a SOC analyst does. So usually an IT staff will set this kind of stuff up. As a SOC, you guys will get violations to those policies and notified for it. That could be either a user trying to install software or somebody's trying to take over that machine. You have to determine what that is. And yes, in this class, you will determine what that is, whether it's real or not real. All right. That's also one good thing about this job that I talked about is it's not just an analyst that goes, oh, that's an issue. I'll kick it up to tier 2. You actually have to go figure out whether or not that was a real issue. And then you write the report, which we'll talk about the report, but that is probably the single biggest deal as a SOC analyst is not only do you hunt down the threats and figure out what's real and what's not, you have to be able to write up a report for that. So if you're not good at writing, guess what? There's tools for that now, right? I think everybody knows what I'm talking about. Everybody write their own report still for class? Don't lie to me, man. Come on. I'll be looking for your reports. All right.
Mine will sound very robotic because I'm autistic. Not
Weird.
any other reason.
Weird. All right. Unix and Linux security. They're renowned for their robust security features with any kind of kernel serving from a core component. The Unix shell or Linux shell is a command-like interface for user interaction. It's where most of us live in the Linux space. But Unix and Linux also have a password authentication system. You're going to see more and more Linux, right? It's happening. People are getting fed up with Windows. Now, you're still going to see Windows in a large corporate environment, all right? It's not taking over in that space. But when it comes to the server side and the services, for example, those of you who are going to deploy in this class, that will probably be on a Linux operating system because that's usually where those services live today. Right. There used to only be a couple top Linux systems out there. Today, there's a plethora of different ones for desktops and servers and everything else in between. Your most common ones are going to be your Debian-based ones, whether it's Debian itself or Ubuntu is probably the two biggest ones. If you go to the CentOS side of the house, you're going to have the Fedoras and you're going to have a couple of the other ones that are out there. Those all have different packet management systems. That's a lot of what you should learn in INF322. Anybody not taking 671 yet?
Linux and networking, right?
First time with Linux?
That was beautiful.
In here?
I played with it.
All right.
I'm
Play a lot.
I haven't taken
I've
it.
taken them doing the same, whatever, Linux unhatched or whatever it's called.
Okay, good. Yep, that's the one I gave you there. Okay, cool. Bo, did you say something, bud?
No, I did.
Or
I'm
Ian?
taking it right now.
Okay, great. If you're taking it in tandem with this class, you should be good to go. If you need to refresh those Linux skills, I can put you in the Linux Unhatched side. I can get you a link for that. That's very easy. That used to be one of the first things I had you do in here just to refresh your command line skills. So,
What do you think about Arch?
Arch is a very, very good distro that I've used in the past. Just know that you have to do everything.
Okay.
Like it's super lightweight, which is great, but you have to do everything. So when you go nano because you can't figure out how to install that, nano's not installed. Them, like not by default. Nothing's installed, you have to install it.
Okay.
So it's very good for extremely lightweight distros. I've used Alpine Linux to act as like a NAT firewall in most cases because I can squeeze it down under 50 meg and make it extremely lightweight.
I was considering having it as my main desktop.
Now the desktop version is probably going to have the stuff running in there. I typically have used the server side, but it's very good because it's very close to the embedded type stuff I used to use back in the day, where you had to compile the Linux kernel and everything else on the fly to keep it tiny, especially when you're installing it on actual physical routers and switches that weren't designed for that in the beginning.
Does the server stuff use the rolling release part of it?
I don't know because it's been a while since I've had to build them. Like once you got one working, you pretty much never touched it. Because it was just, I used it for small single service applications. And it's because it wasn't bloated. So an Ubuntu server minimal install still has a lot of stuff in there. Alpine is literally 50, 100 meg and you have a VM ready to roll. So cool. But in this class, I strongly encourage you guys to run Linux at some point. So put it on your laptop as a VM. If you're really brave, run it as a daily driver for the next, 3 months in this class, because you will live, eat, and breathe Linux in the real world. All right. Web application fundamentals. This is just kind of covering the client server architecture that most of you are familiar with, where again, we are sending and hosting those services out on the server itself. And then the client is going through that network to pull those services down. In our case, HTTP is all but dead in most cases, right? That used to be the default. Now everything's HTTPS. But to make HTTPS work, you typically need to have certificates and things like that for authentication, validation. which costs money, and that's how HTTPS goes about it.
Let's encrypt.
So you also have the options for Let's Encrypt going through there. Yep. Now, there's many services that you can use Let's Encrypt for. There's many services that Let's Encrypt would be a pain because that certificate renews every 30, 90 days, right? Kind of depending on what it's set up. So it has its use cases, but it's not perfect. Anybody have any questions on HTTP, HTTPS? What port number does HTTP run on?
443 or 80. Yes.
80 for HTTP, 443 for HTTPS. All right. Information security standards, lacks and laws. Obviously, if you guys are at the SOC, you need to know the laws because a lot of this is what do you do when you find a violation, right? And so when you find a violation, you have to not only document it, but you have to collect that information in a way that would be compliant with whoever's going to do the prosecution, right? So if you were doing this at a government level, like for example, for the state or the city or something like that, you would work directly with the prosecutor to get this conformed in a certain way. This kind of gets into the forensic side of the house when you're collecting this information and then getting that to somebody to do that. At the same time, you guys have to make sure you're following that stuff so that you don't corrupt the logs just by looking through the logs kind of thing. That was one thing the employer really wanted to emphasize was that just because most SIMs actually bring in all the logs and you guys are reading through the logs, we can fake logs, right? We can edit logs, we can fake logs, we can do all sorts of stuff. So don't take them as a source of truth. What is the main source of truth on a network? What's the network built for?
Users.
Users doing what?
Traffic. I mean,
the traffic on the network is always going to be your source of truth. If you can pull samples of the network traffic or you can watch the network traffic, that is by far better than logs because at that point it hasn't been logged, right? We're watching it live on the network. So your Wireshark, having your Wireshark skills, or being able to pull those packets into something that can analyze it. With us being in the day and age of AI and machine learning and all that, there's tons of tools that basically plug into the network and is like a Wireshark on steroids. It will tell you what's going across that network on the fly and whether or not that's good traffic or bad traffic or et cetera, et cetera, et cetera. All right. These are some standards that you should be familiar with. The Cybersecurity Information Sharing Act, HIPAA down at the bottom. The ISO 27001 is particularly useful for your information security management system stuff, your ISMS stuff, risk management, security protocols, that kind of stuff you guys will need to be familiar with. NIST 853, that one has been for federal systems, including access control, baseline configs, things like that. These are all standards. So you guys will end up building baselines that meet these standards, or you'll use software that meets these standards to take care of you being eligible for that. Right. The GDP type stuff that you see at the bottom, we can thank them for the nice little allow cookies at the bottom of every single website now. That is what that's from. Anybody not know that? You ever been browsing the internet and see all this stupid allow cookie stuff at the bottom? That's thanks to the GDPR laws that were down there. Okay, we can all thank the EU for that collectively. And what that is important is if you guys are hosting a service and I as a user say, you must remove all of my data, you must remove all of that person's data. You can imagine how difficult that is for systems that were not written in such a way to remove individual users' data. Which means when this first came out, you were literally going line by line in databases and logs and anything else trying to remove user data out of there. Because by law, you were required to do it or you could be sued. Even though we're not in the EU, you could still be sued. It was a large, large headache when it all came out. The company I worked with at the time when it did come out, we had to rewrite a lot of stuff to be compliant in that regard. All right. That's it. That's kind of the overview for this is basically understand and recap your TCP/IP OSI models read back through them, know what they are. The quiz is going to cover some of those, what models, what, et cetera. Network types, you're going to see LAN, WAN, MAN, and the different topology types, bus, star, ring, the physical layouts, knowing all the different network hardware components, routers, switchers, cables, policies, access controls, firewalls, IDS, IPS. We didn't technically mention that. Does anybody know what IDS is?
Intrusion detections
System. Yep. And IPS?
intrusion prevention system.
And what's the difference between the two?
Prevention
One finds it, one stops it.
like blocks.
Correct.
IPS is like
Yep. Those could be all of one device, where it's a firewall, IDS, IPS all in one. You could also have separate IDS and IPS devices even of themselves. It could do both functionalities or separate. You guys will deploy some stuff that is just an IDS in this class. So for example, another one you guys can look up is Zeek, ZEEK. That is what we will use for doing IDS style detection. It can also do some IPS style detection in there as well. But Google search that up. Old days, it was called BRO, BRO. Now it's called Zeek. And then there's another one that you should be familiar with called Snort. And you will see it as, yes, like a pig snorts, because it's a picture of a pig for snort. Snort is like the basis of all rules when it comes to this kind of stuff. Meaning that you take snort rules, you write those, and then it works into all these other devices and pieces. So at least being able to talk intelligently to those, you may not have had hands-on, you'll get that in the class, but being able to talk intelligently to those will definitely beef up your resume. Anybody got any questions on this? So what is due this week? Come in here, take a look at your lab assignments. You guys should get access to the EC Council lab platform. I believe there was, 3 lab assignments this week?
We have to buy that thing you put on.
Yeah, that original link up here for purchasing the link. So when you purchase this deep link, which will take you out here, this one here, you will get access to their lab environment, as well as the exam prep, the book itself, and the exam voucher. All right. For now, you'll activate their labs.
Do I have to do anything with the other one? The key on the other link? Or
No.
what
So
is that?
you'll end up getting, I believe, 3 or 4 keys. You will just want to redeem the one for the book and for the labs.
Okay, I just didn't know. Oh, so that is the other slide.
No. So when you
Sorry.
purchase
If you go to
this one here,
Yeah.
this just tells you how to redeem it. These are videos that show you to make sure you put the right key in the right spot.
Oh, okay.
So yeah, like this one, when you want to talk about the keys and how to do that, how to get in the lab environment, that kind of stuff, that's all these are. For a while, people were getting really confused, so EC Council put out videos for all that. Because when you purchase, you end up with like 4 emails and 4 keys, and it can be a little confusing. If you follow all those directions, it's very, very clear. If you have issues when you try to activate that and stuff is not working correctly, do make sure back at the bottom of this one that you contact a support, and they will make sure that your keys are valid and everything going in between them. All right. So the 3 labs and the quiz will be due by Sunday at midnight. And I'll put those in there. I'll get timestamps in there. Thursday, when we come in here, you guys will have time to probably take the quiz, but I'm going to try to pull out different segments. This week, I'll be honest, there's not additional overflow for Thursday. You know what I mean? Read through the material, go take those labs, do that. If you guys want to do one of the labs in person in here, we could do that on Thursday. That's typically what I do on the second day, is the lab stuff. So we'll do a sampling of the labs. All right. You're free to go.
Do you have a class at